Hey y'all, what's up? Coach Hyde here. Second part of Unit 8 videos here, moving into identifying ionic and covalent compounds. So this is just on if it is ionic or if it is covalent, and what does that mean. This is not about naming, this is not about writing formulas, those are in the other videos. So we're just trying to figure out, hey, let me look at this, is it ionic? Or hey, let me look at this, is it covalent? All right, so first off, I got this left up here from the last video. The easiest way to figure this out, if it's ionic or covalent, is to look for a metal. If you see a metal, it's ionic. Over with. All right. So for what we're doing now, there's as you advance through this, there's going to be other situations where maybe you have a positive ion, polyatomic ions, things such as this. So you'll expand on this knowledge in the future. But for right now, for simplicity of it, if we see a metal, this ionic, right? That means it has a positive ion in it. It's ionic. If it does not have a metal, right? If it's just made up of these non-metals here, then it's covalent. That's it. That's the most basic way I can tell you to identify it. And that's the fastest way to do it. Okay, so if it has one from each side, if it has one of these, anywhere over here, these metals, except for, hydrogen, then it's ionic. If it does not have one of these, then it's covalent. Okay, and then you'll follow your rules for naming or writing formulas based off of that knowledge, because ionic has its own rules, covalent has its own rules. The biggest mistake students make is you don't check that before you go. You just start naming it or you start writing formulas. You got to check first. I can't emphasize that enough. I'll probably say it 20 times throughout the next couple of videos. All right, so start with ionic. Okay, we'll start with the basics of ionic. So let's say calcium and oxygen met in a room somewhere, right? Calcium has 2 valence electrons, right? Oxygen has 6, okay? Calcium's in group 2 on the periodic table, right? Little 2 up there. Oxygen's in group 16. Okay, so 2 valence electrons, 6 valence electrons. Now, when it becomes an ion, we also know if it's in group 2, it'll become positive 2 ion. If it's in group 16, it will become a negative 2 ion. Hopefully we still remember that at this point. So what's going to happen here? They have to kind of be in the room together. Right? Calcium is going to want to give away these electrons. Okay. So when they're gone, once they are transferred away, that's when it becomes, positive 2. Right? Now when oxygen gains these 2, that's when it becomes negative 2. They are ions. Okay. Now, positives and negatives, electrostatic forces. We know the opposites attract. Okay, so positive 2 and negative 2, right? They're going to attract. When they attract, they're going to come together. So now we'll have CaO. Okay, now we have a positive 2 and a negative 2 charged together. So when they're bonded together, their overall charge is neutral, right? It's positive 2 and the negative 2. Well, if you add those together, right, plus 2, and you add that to negative 2, you get 0. So the overall charge of this compound here is 0. This is an ionic compound. We know this kind of from 2 basic ways, right? There's a metal there, like I talked about before. Also, electrons were transferred. And if electrons get transferred, then it's ionic. If it's a bond between 2 ions, it's ionic. Right? Now, something that these things will do, right? So, I'll use another example. Let's do sodium. Let's just do sodium and oxygen. Okay? Sodium, still going to use oxygen. Sodium's in group 1. So it has 1 valence electron, it'll give away 1, it'll become positive 1. All right, so we know it's an ionic compound because it's got a metal. Sodium's a metal, it's on the left of the periodic table. We know it's going to be ionic because we're going to talk about ions bonding, right? Sodium, okay, oxygen. We're going to bond. Now on this one, we're going to need 2 sodiums, right? Because if this sodium transfers an electron, oxygen still needs another one. So we're actually going to need 2 sodiums here to make this happen. Right? So the bond here is going to be Na plus 1, Na plus 1, O minus 2. Okay? They're all bonded together, right? This one and this one are bonded to that. And the charges balance out to be 0. So, ionic, right? We got electrons transferring, we got ions, we got charges, right? And our fail-safe is there's a metal, so we know it's ionic. These things, because it's like magnets sticking together, and you can keep sticking magnets together and together and together. So they'll make like this, it's called a lattice structure, right? So Na, O. We'll start to get this like repeating pattern, right? So then it'll be like O, right? Start to get this repeating pattern. Lattice structure. This is like your big blocks of salt, right? They all kind of stuck together. You got to break them apart. And all this is negative charges, right? So if I take out the Na, I'm showing you this because we'll have some pictures on it, and it won't look like, you can't tell it's a metal, you can't tell what's happening, but what you'll see is a bunch of circles like this, and then you'll have like, you know, some charges. Right? And this kind of web of positive and negative charges stuck together. And we would know that that is ionic too, because we know the charges are holding them together. If you've got charges holding together, then it's ionic. Okay. So that's it for ionic. Ionic. Ions. Metals. Right? The big takeaway is you're looking for metals. There's a metal there, it's ionic. You're looking for charges, positives and negatives, ionic. Looking for electrons being transferred back and forth, ionic. Okay. What about covalent? Covalent is not going to use ions because ions are ionic, right? What covalent is, okay, let's say we'll keep up with oxygen, right? Oxygen has 6 valence electrons. The oxygen we breathe in is O2. That's the form it floats around in and stuff like that. 2 oxygens bonded together. Well, if they made an ion, let's just pretend we'd have -2 and -2, right? Because oxygen makes -2 ions. What are 2 negatives going to do? They're going to repel. So they're not going to be able to bond like this. Okay? However, they still need 8 valence electrons. So oxygen needs 2. This oxygen needs 2. So how are they going to do that? How are they going to bond together? They're not going to transfer or give or take. They're going to share. And sharing is caring. Right? So what they're going to do is they're going to kind of move around a little bit. Right? Kind of look like this situation here. Right. So now right here they're sharing. Sharing. They're caring. Sharing is caring. Right? So when you're sharing something, technically you both have control of that thing, right? My wife makes me share my ice cream with her, and I hate it, okay? Because technically we both have that ice cream. It's both of ours, but I don't want her to have it. I want it to be my ice cream because I like the ice cream. But we're both eating out of the ice cream tub together, right? We're sharing. Sharing is caring, right? So with these electrons, this oxygen has all of these electrons. Okay, they're all of that oxygen's electrons. So it has 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen here also has all of these electrons. So it has 1, 2, 3, 4, 5, 6, 7, 8. Right? So their sharing is covalent. There's no metals there. It's covalent. Right? Another way you can kind of draw this same picture here, and we'll scoot back a little bit. Right? If we draw out oxygen, okay, it's going to have 2 electrons in the first level. It's going to have 6 electrons in the second level. We'll draw another oxygen here. Right. It also has 2 in the first level. I'm going to draw it a little closer. And it also has 6 out here. Okay. So these electron shells kind of overlap. And what that is showing, right, this is not how it exists in the three-dimensional world and all that, but what this is showing is the sharing of electrons in that area. So if we see this happening right here, we see these shells overlapping, right, and the electrons in there, they're sharing, right? So this has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. It's good, it's full. This one has 1, 2, 3, 4, 5, 6, 7, 8. They both have control of that. So when you're dealing with this covalent, is there a metal? No, no metals in covalent. If there's a metal, it's ionic, right? Are they sharing? If they're sharing electrons, then it's covalent. If the electron shells are overlapping, it's covalent, right? Something I'm not really going to ask you about, I'm just going to kind of show you a little bit about it, is there's a couple different types of covalent bonds. We got single bonds, double bonds, triple bonds. So something like fluorine, right? Fluorine has 7 valence electrons, right? Let's say it bonds with chlorine. Chlorine also has 7. Okay, so they both need 1. So they're going to share 1 each. They're going to have 1 pair of electrons, right? So that is a single bond. They're sharing 1 pair, right? A pair is 2. So 2, 4, 6, 8. 2, 4, 6, 8. So they fulfill that with a single bond. Another way is a double covalent bond, which you just saw with oxygen, right? When we bonded oxygen together, they shared 2 pairs, so 4 total electrons. So 2, 4, 6, 8. 2, 4, 6, 8. And that satisfied theirs. Another one would be like nitrogen. Nitrogen is going to make a triple bond. So 2, 4, 6, 8, 2, 4, 6, 8. So not really going to go into a whole lot of that. Just know that this can kind of work out different ways. You can share things depending on how many you need to share. You can share, water, oxygen. So as you know, oxygen needs 8, but H2O looks like this, right? So it doesn't have to just bond with another oxygen or just bond with one other thing. It can bond with like 2 hydrogens. So this way it would have 2, 4, 6, 8 valence electrons. Hydrogen is in that first level on the periodic table, so it only needs 2. So it's just going to need 1 sharing pair, 2 and 2, right? Hydrogen and helium are full at 2. Everything else is full at 8. So there's a lot of different ways you could do this. Nitrogen can go with hydrogen like this, right? Carbon can make 4 pairs, 4 bonds, which is why it's so awesome and so essential to life. It can bond with like everything, you know what I mean? Because it can give up 4 pairs, or it can share 4 pairs. So that's pretty much it. Best I can do, short amount of time. So when you're trying to figure out if it's ionic or you're trying to figure out if it's covalent. Ionic. What? Metal. Yeah, metal. Ionic is metal, right? It's got a metal ion in it. They're transferring electrons, right? One of the metal electrons is giving its electrons to the non-metal. Non-metal becomes negative, right? Metal becomes positive. Positive and negatives attract, right? So they're stuck together by ions. Covalent, what? Yeah, no metal. Covalent is no metal. No metal there, right? Right now. They are going to share electrons. Covalent shares because covalent cares. Don't forget it, right? So that's pretty much it. Make sure you look at the periodic table, that little stair-step line. The non-metals are over there, right? The metals are this way. I don't know if I did it right, but if your noble gases is your non-metal side, and then the transition metals and all that's your metal side, and hydrogen is a non-metal as well. And that's it. Make sure you take a second. Identify, is it ionic? Does it have a metal? Does it transfer electrons? Yes, it's ionic. or is it covalent? Because what we're about to do right now, you're going to have two sets of rules: ionic rules and covalent rules for both naming and writing formulas. So I'm not going to go into this much with those videos. I spent 15 minutes on it right now, right? So check to make sure it's ionic or covalent before you go further. Every time, all the time, no matter what. I'm serious. Check it out. Is it ionic or is it covalent? It matters. It matters to me and it matters to you. All right, I'm out. Making another video.